For section 6.5 and for some of the Q problems and just for the future in general, you need to know how to find areas of different kinds of shapes. And I wanted to look at some of the really basic formulas first. Now, a lot of you may know these. This may not be a big deal. If so, just kind of scan through the list real quickly, and after you do that, you can move on. For those of you who have forgotten some of these, I'm going to run through each of these very briefly. So, the area formulas I want you to know. I want you to be able to find the area of a triangle, the area of a rectangle, the area of a parallelogram, area of a kite, area of a rhombus, trapezoid, equilateral triangle, and circle. Okay? So I'm going to step out for just a moment here and let you think about those formulas. You can stop the video, maybe fill out those area formulas just to verify that you've got them, and then I'll come back and I'll explain them. Hopefully you've had a chance now to list these out. We're going to pick up and take a look at each of these formulas. First of all, the area of a triangle, 1/2 the base times the height, or you could say base times height divided by 2. Okay? Make sure you have the actual height. The actual height of a triangle is an altitude. Okay? So for example, if this length is 10 and that length is 5, you could take half of 10 times 5. Area would end up being 25 square units. Okay. Of course, a rectangle, the area is just the base times the height, or you can think of it as the length times the width. It doesn't really matter. Either one of those is just fine. For a parallelogram, be careful. A parallelogram is leaning. Okay. Technically, and you've probably talked about this sometime in past courses, but you can take this triangle and you can move it over here and you can turn it into a rectangle. The point here is, just like a rectangle, you're finding the area by taking the length of the base and multiplying by the height, okay? Not the lengths of the sides, okay? So if the base is 10 and the height is 5, even if this length over here is something else, you're still going to take the base times the height. Okay, 10 times 5 is 50, okay? In other words, if you move this triangle over here, that height would still be 5, and that base would still be 10. It'd still be a 10 by 5. So parallelogram area also is just base times height, all right? A kite. Kite can be handled a couple of different ways. You probably know that the diagonals are perpendicular. The diagonals will create right triangles, and you could, in fact, do different things with those. One option is you could basically find the area of this triangle. You would have its base, and you would have its height. And then you can find the area of that triangle, and you can double it, and you can find the area of the total kite. That leads to the formula for the area of a kite, which again you've probably seen previously. The area of a kite is actually just half the product of the diagonals. Half of diagonal 1 times diagonal 2. Okay, so if this diagonal length here is 6 and the diagonal length here is 10, you can take 1/2 of 6 times 10, and the area is going to be 30 square units. Okay, or again, you can take just this triangle here. It would have a base of 10 and a height of 6, and you can find that area. Okay, it would have a height of 3, I guess, and then a length of 10. I guess the area would be 15, and then you can double that. So you know you can break it up into parts if you need to. A rhombus. A rhombus is interesting because a rhombus is a parallelogram. So if you've got a base and a height, you know, if the base is 10 and the height is 6, you can just take the base times the height and you can get the area, no problem. Keep in mind that a rhombus is also a kite. So if they give you diagonal lengths for a rhombus, of course the rhombus has perpendicular diagonals. It will break up into a bunch of right triangles. So you can also find the area of one of those triangles and multiply it by the appropriate value to find the area. But yeah, if this diagonal, for example, is 8 and this diagonal is 10, you can just take half the product of the diagonals and get the area as well. So base times height, or 1/2 the product of the diagonals, depending on whether or not you're viewing the rhombus as being a kite with equal sides, or whether or not you're viewing it as a parallelogram with equal sides. Okay, a trapezoid, pretty famous formula for a trapezoid. The area of a trapezoid, remember that a trapezoid has upper and lower parallel bases. So you might call this base 1, you might call this base 2, maybe your height's going to be right here. The area of a trapezoid is found, and it doesn't have to be isosceles, by taking 1/2 the height times the sum of the two bases. Okay? So for example, if this base was 10, and this base was 8, and this height was 5, write 5 there, that would be half the height of 5 times the sum of the two bases. Okay? This is 18. 18 times 5 is 90. Half of 90 is 45 square units. Okay? That would be the area in this particular case. By the way, you can do this in different orders. For example, if you take 8 plus 10 and take half, that's actually the average of the two bases. And then you'd be multiplying it by the height. So sometimes I think of the area of a trapezoid as being the average of the bases times the height. And that'll also work, okay? So in other words, the average of 8 and 10 is 9. 9 times 5 is 45, and you get the same answer. So kind of a quick way to do it. Maybe not the formula that you see in most textbooks, but something that can work. Area of an equilateral triangle, of course you don't need a special formula for this. If you just want to fill in the side lengths, you've got little 30, 60, 90 triangles here, so this length is going to be 4. That's going to be 4 radical 3, so you could take half the base times the height here. I think you'd end up getting 16 radical 3. So that's an option. There is a special formula. If you remember, I think we briefly developed it in class. It was one of the homework problems. You can take a side squared, divide it by 4, and multiply by radical 3. So especially for shapes that break up into equilateral triangles, for example, like hexagons, this can be kind of useful. So in this example, if the side lengths were 8, that would be 8 squared over 4 radical 3. You can see that would be 64. 64 divided by 4 is 16, and you'd end up with an area of 16 radical 3. So it can be very quick. Of course, a circle, very famous formula, pi times the radius squared. And so, again, make sure you know that formula as well. If I had a circle with a radius of 4, for example, the area would be 16 pi. Okay, write your answers in pi form. All right, so I'll get out of the way here. I'll let you take a look at those formulas. Make sure you have those somewhere in notes. Okay, they're going to come up again and again and again. There's just no reason not to know these formulas, quite frankly, all the time.